In this video, we're going to look at what alternating series are and the test to determine if alternating series are convergent or divergent. The first thing we're going to look at is what is an alternating series. So if you remember right, a series is just a sum of a sequence. An alternating series is ones where the terms are alternately positive and negative. So we have two examples here. The first one starts off positive and then goes negative, so it's 1, negative 1/2, 1/3, negative 1/4. The second one starts off negative and goes positive, so it's negative 1/2, positive 2/3, negative 3/4, positive 4/5. It can do either one. Notice how the exponent is on the negative 1 in the summation. If it's just negative 1 to the nth power, you're going to get a negative starting value, and then it's going to go negative positive. If it's n minus 1 or n plus 1 in the exponent on the negative 1, you're going to get a positive value first, and then it's going to go negative. Now we're going to look at the alternating series test. The key with the alternating series test is that we're only going to be looking at the values of the actual series. So we're only going to be looking at the b to the n when we're doing the calculations for this. As long as it's negative 1 raised to a power, we know it's an alternating series and we can use this test. The two things that has to satisfy for it to work is that it has to be getting lower. So it has to be decreasing as the terms are going up. So b to the n plus 1 has to be less than or equal to b to the n. The other test that it has to work is that the limit of b to the n has to equal 0. So as it's going further and further out to infinity, it has to reach 0 at the end. Now we're going to go into a couple examples, and we're actually going to use this to test if the alternating series is convergent or divergent. So now we're going to start looking at some examples. This is example number 1. If you remember, in the last class, we looked at the harmonic series and said that it is divergent because when we did the integral test, it went to infinity. So the alternating harmonic series is a little different. The alternating harmonic series is still 1 over n, but it's got the negative 1 values plugged in there as well. So it starts off positive and goes negative. So it's 1, negative 1/2, positive 1/3, negative 1/4, and so on. So let's look at the alternating series test and see if this series is convergent or divergent. It's got to pass it's got to satisfy both criteria. So the first criteria states that the series is decreasing. In this case, it is. 1 over n plus 1 is definitely less than 1 over n. The second criteria that it has to meet is that the series, the limit, has to equal 0. And as n goes to infinity, 1 over n goes to 0. Since it satisfies both those criteria, this alternating series, the alternating harmonic series, is convergent. All right, in example number 2, we have the series that's listed on the screen. And we're going to try to test this by the alternate series test to determine if it's convergent or divergent. So the first thing we have to look at is, do we know if it's alternating? Yes, it is alternating. The second thing that we have to look at, the two criteria, is it decreasing? And does the limit go to 0? So if we look at the first thing, let's see if it's decreasing first. So I have 3n plus 1 over 4n plus 1 minus 1 is less than or equal to 3n over 4n minus 1. So in this one, the numerator is getting bigger and my denominator is getting bigger. So unfortunately, it makes it really difficult for me to determine if that's decreasing or not. So let's look at the second criteria. And if the second criteria works, we'll come back and look at the first criteria and actually work on it to make it work. But if we look at the second criteria says the limit as n goes to infinity of 3n over 4n minus 1, that has to equal 0. Problem is, this one doesn't equal 0. This one actually equals 3/4. So it does not equal 0. So this fails the alternating series test, so it is not convergent. To determine if it's divergent, we have to look at the test for divergence. The test for divergence states if the limit does not go to 0, it is divergent. So in this case, my limit does not go to 0. So therefore, this function, or the series, is divergent. So in this example, we're going to try to determine if it's convergent or divergent by looking at the alternating series test. This is an alternating series. So the first thing we have to look at is if it's decreasing. Again, if we look at the n squared plus over n to the third plus 1, if I change it to n plus 1 on both the top and the bottom, it's going to be very difficult for me to determine if it's automatically less than that. So another method we can use to do that is determine if the derivative is always going to be less than 0 or negative. So the first thing I have to do is take the derivative of the function, and that's going to give me x times x2 minus x to the third over x to the third plus 1 squared. Since I only care when the derivative is less than 0, I don't care about the bottom, because the bottom is squared, so it's always going to be positive. So I only need to worry about the top. So I'm really looking for where x times 2 minus x to the third is less than 0. So that means, well, the first one is x has got to be less than 0. And then I have 2 minus x to the third is less than 0. So I get x to the third is less than, or is greater than, so I have to switch it, 2. So it's the cubed root. So x has got to be greater than the cubed root of 2. As long as x is greater than the cube root of 2, I have a decreasing function. Since we now know it's decreasing, I can go on to the second step. The second step says I need to look at the limit. So we're going to look at the limit of this function as n goes to infinity of n squared over n to the third plus 1. So I'm going to divide them all by n squared, and I get 1 over n plus 1 over n squared. So as this is going to infinity, the bottom of this function goes to infinity, so the function goes to 0. Since my limit's going to 0, and it was decreasing, therefore this series converges by the alternating series test.